December 25th, 2021. NASA launched the most powerful space telescope ever, the James Webb Space Telescope. With this amazing tool, you can actually time travel, but not in the way you might think. It's not about going back in time physically, but with it, you can peer into history. And I'm not talking about just a few decades back. This telescope lets us glimpse into events that happened billions of years ago, specifically 13 billion years. That's right, the universe started with the Big Bang 13.8 billion years ago. And the James Webb Telescope can help us see all the way back to just 0.7 billion years after it began. Curious how it's possible? In today's video, we'll break down how this all works. The James Webb Space Telescope is special because it's built to detect infrared light. Now, regular telescopes let us see visible light, the light we can spot with our eyes. Remember learning about the electromagnetic spectrum in school? It includes everything from X-rays and microwaves to radio waves, and only a small part of this spectrum is visible light. Standard telescopes work by observing this visible light range, from blue to red, where red has the longest wavelength. Now, the larger the wavelength, the easier it is for waves to pass through objects. Think about how radio waves travel through buildings. Same idea. Infrared light has an even longer wavelength than red, but we can't see it. That's where the power of infrared telescopes like Webb comes in. When you look at space dust or gas clouds through the Hubble Space Telescope, you see what's in front of them. But Webb can cut right through those clouds to reveal what lies behind. Here's an example. On the left, Hubble's image of space dust, and on the right, how Webb will show us a clearer view thanks to infrared technology. Infrared waves are emitted by everything that radiates heat, from the sun to humans. That's why night vision goggles work by detecting infrared to see in the dark. This means Webb can see things we've never seen before. And when looking at distant stars, their light gets stretched out, a phenomenon called the redshift. This effect is key to understanding galaxies billions of light years away. The telescope's mirrors are massive, and the bigger the mirror, the better the telescope can collect light and create higher quality images. The Hubble telescope's mirror was a certain size, but Webb's is a lot larger. Plus, Webb's entire mirror is coated with 24-karat gold, which helps it reflect infrared light. One thing you should know is that Webb also needs to stay super cold, around negative 223 degrees Celsius, so it doesn't emit its own infrared waves. That's crucial for capturing sharp, undistorted images. Space is incredibly cold, but the problem is that any sunlight hitting the telescope could rapidly heat it up. To prevent this, Webb has a giant sun shield about the size of a tennis court that blocks out the sun's heat. This sun shield is made from a material called Kapton, which has been specifically designed to keep Webb cool. It's made up of 5 layers, each thinner than a human hair, and the layers are separated by a vacuum to improve effectiveness. Webb won't be orbiting the Earth like Hubble. Instead, it's stationed 1.5 million kilometers away, at a special spot in space called the Lagrange Point 2, L2. At L2, Webb stays behind the Earth as it orbits the Sun, keeping it in the Earth's shadow and blocking any unwanted heat from the Sun. This location helps Webb stay in constant, perfect alignment to take sharp images of deep space. Building and launching Webb was an extremely complicated process, with over 300 potential problems identified along the way. NASA, the European Space Agency, and the Canadian Space Agency have all worked together to make this $10 billion project a reality. The hope is that Webb will provide answers to some of the biggest questions about the universe, like how stars and galaxies formed after the Big Bang. The key to understanding how Webb looks into the past is that light takes time to travel. When we look at the sun, for example, we're seeing it as it was 8 minutes ago, because it takes that long for sunlight to reach Earth. This is true for all the stars and galaxies Webb is studying. Light that travels billions of light years takes billions of years to reach us. So when we look at distant galaxies through Webb, we're seeing them as they were billions of years ago. If we could build a telescope far away from Earth, say 100 million light years, and point it back toward Earth, we could theoretically see it as it was 100 million years ago, maybe even witness the time of the dinosaurs. But practically speaking, it's way too far for humans to reach, so it's just a fun idea for now. In addition to peering back in time, scientists are hoping Webb will help us find planets that might have Earth-like conditions and possibly even life. There's so much to discover, and this telescope will give us the best views of space yet. I hope you enjoyed this deep dive into the James Webb Space Telescope. If you're curious about space, wait for my next video on space tourism, or explore more of my science-related content here. Thanks for watching, and I'll see you in the next video.